Hello and welcome to this new video, and in this video we are going to look at distance along circle of longitudes and latitudes. So we are still looking at our study focus Earth geometry. This is just an advancement from where we ended. Now, in the previous two videos, we looked at the basics, how to use latitudes and longitudes to allocate positions or towns on the Earth's surface. And the second video, we looked at how to calculate the differences between latitudes and longitudes. In this one, we are going to look at how to calculate the distances along circles of latitudes and circles of longitudes. Now, before we get into calculating the distances along the circles of latitudes and longitudes, we have first of all to do some few basic steps that will help us understand more about distance along circles of longitudes and latitudes. So let's look at the next step. So here we have to calculate the radius of a circle. Okay. Here we are looking at the circles of latitudes. So if you've observed from the previous diagrams I've been showing you, you would see that whenever we have the circles of latitudes, you would see that as the latitudes are heading towards the North Pole, somewhere there, you would see or observe that the circles are actually reducing in size. From the greater circle here, which is formed by the latitude 0 degrees or the latitude equator, you would see that as latitudes are forming circles towards north and towards south, the circles are reducing. For example, if I was to give a quick demonstration here, okay, to say, let me draw another latitude heading towards north. Have you seen that the circle will reduce? It will be smaller than this circle here. As much as we can see, this circle here is also smaller than the greater circle formed by the equator. So, meaning that as we are heading towards north, the radius of these circles reduce. As the circle is becoming smaller, the radius is reducing. So the greater circle has a radius which is standard, in both given in kilometers and in nautical miles. Okay, so in a bit we'll get to that. Now, first thing is I want us to understand the diagram here. So the O is the center, okay, of the Earth from the greater circle there. Okay, and R here is the radius. Okay, is the radius for our greater circle. Okay, and then B is a point which is lying on latitude, okay, x degrees. Why am I saying x degrees? Because if you look at the angle here, the angle here is x degrees, meaning that is the angle defining the latitude where point B is lying on. Remember about the diagram I showed you in the first video on how to name latitudes. Okay, so how can we calculate the radius of the parallel latitudes? Or how can we calculate the radius of circles of latitudes? It's simple. We are going to use a concept from trigonometry. So you can see that OBM is a right angled triangle. Okay? Therefore, we only have to apply SOHCAHTOA. Okay? SOHCAHTOA. I think you can still remember this. SOHCAHTOA. Okay. Now, you can see that R is the longest side. So meaning that is going to be our hypotenuse. So R is the hypotenuse. Okay, and you can see that our angle is x here. Okay, that means that small r is actually adjacent to angle x. Adjacent to angle x. So that taken note. Let's apply the SOHCAHTOA and see how we can get radius. Okay, so let me just do the calculations here. I'll do the calculations, just allow me to do them here. So meaning that we will say which one is going to apply here. Okay, is it SO or CA or TOA? Which one is going to apply? We are going to look at the ratio, trigonometric ratio that has the two things we have on our triangle, which is hypotenuse and adjacent. So you can see that right here, CA is going to help us because it has both adjacent and hypotenuse. Therefore, we can say, allow me just do it from here. We're going to say CA, that means cos x degrees, okay, which is our angle, this one here, okay, is equal to, what is our ratio? Adjacent over hypotenuse. So adjacent over hypotenuse, right? Now, what is our adjacent? It's small r, and our hypotenuse is capital R. So we can do the replacements. So we can say that will be equal to R over R. Okay, take note of that. So let me just do some rubbing there, and then I have some enough space. Okay, so we're going to have cos theta, which is our x degrees, is equal to R over R. So remember, we are calculating radius for the parallel latitudes, which is the small r. So over 1, and then we can cross multiply. So we're going to have R is equal to R cos x degrees. So meaning that the formula that we'll be using to calculate radius of parallel latitudes is exactly what we have here. Okay, let's try and see how we can use it in a real situation. Okay, let's try and see how we can use it in a real situation. I got a question from, okay, I got a question here for you. First, before we get into the question, take note the radius of the Earth on top here. Radius of the Earth is approximately 6,370 kilometers. That is the standard radius of the Earth. It does not change. That is the radius coming from the greater circle, okay, which is the capital R here. This one here is always going to be 6,370 kilometers. Let's look at how we can solve this problem here. Find the radius of the circle of latitude 60 degrees north. 60 degrees north. Given that the radius of the Earth is 6,370 kilometers. Therefore, to solve this problem, we now know how to calculate radius of any latitude. We said R is equal to R cos, okay, x degrees. That is the formula. So meaning we're going to say R is equal to what is excuse me, what is capital R, which is the radius of Earth. So 6,370 times cos the degree for the latitude is 60 degrees. Okay, that is the degree of the latitude. Don't forget that this is degree of the latitude. So now we can say 6,370 times cos 60 is half. Special angles, I think you can remember this. Therefore, we can now say what is 6,000, okay? 6,370 times half, which is going to give us 3,185 kilometers. So that is our radius. So our radius is 3,185 kilometers. Okay, let's try and see about nautical miles. So basically, what I can simply say is that apart from a mile and a kilometer, navigators, pilots, captains in ships also use a measurement known as the nautical miles as a unit for measuring distance on the Earth's surface. So another commonly used name for nautical mile is sea mile. Okay, so a nautical mile is the distance on a greater circle which subtends an angle of 1 minute at the center of the Earth. Okay, so the diagram on the right side is exactly demonstrating what that statement is trying to say. So it subtends an angle on the center of the circle, which is exactly 1 minute. Okay, now how do we calculate the circumference of the Earth in nautical miles? So here is how you can calculate the circumference of the Earth in nautical miles. The first thing you have to do is understand this ratio. 1 minute, okay, is to the ratio, okay, let me just show that, is to the ratio 1 nautical mile. This should be equal to 360 degrees to the ratio circumference. So on the ratio there, just put my dots. My ratings is not that clear. Okay. Now, let's get on to the calculations. The 1 minute here, okay? The 1 minute here is out of what? 60 minutes to make an hour. So what we're going to do is, we're going to illustrate that to say 1 minute is out of 60 minutes to the ratio, okay, to the ratio 1 nautical mile equal to 360 degrees to the ratio circumference. The C is for circumference. Okay, so we can now say, let's express this in ratio form. So 1 over 60 minutes will be over 1 nautical mile is equal to 360 degrees will be over C as circumference. What we have on the left side shouldn't really be confusing. This simply means 1 over 60 divided by 1. So let's rewrite that. It simply means 1 over 60 divided by 1. That should be equal to 360 over 1. Over C. So this will change to multiplication. It will be 1 over 60 times 1. So it's going to give us 1 over 60 is equal to 360 over c. Then we can cross multiply. So c multiplied by 1 is c. That should be equal to 60 times 360. That is going to give us 21,600 nautical miles. So if in the exam you've been asked to show or prove that the circumference of Earth is 21,600, that is the calculation you can show to finding the circumference in nautical miles. The circumference of the Earth in nautical miles. Okay, let's try and see how we can then calculate radius. So just more examples to ensure that we are all comfortable with the calculations. Okay. So the question here says, a circle of latitude has radius 4,100 kilometers. Find the latitude given that the radius of the Earth is 6,370 kilometers. So we know that radius is equal to radius of Earth cos x degrees, which is theta. So we've been given that a circle of latitude has a radius. So the radius has been given as 4,100 is equal to the radius of Earth has been given as 6,370. That is in kilometers. That should be times cos. Okay. The angle has not been given, so it's the one we are looking for. Meaning we're looking for the degree of the latitude. So this will be over 6,370 over 6,370. Then 6,370 divided by 6,370 will give us 1. 1 times cos theta degrees will be cos theta degrees. So we are going to have cos x degrees is equal to 41,100 over 6,370. So how can we get the angle? Remember, trigonometry says for you to calculate the angle here, meaning that you have to find the inverse of cos. So meaning we're going to say x degrees is equal to cos -1 41,000 over 6,370. Okay, you have to punch the inverse on a calculator, which is going to be found by accessing the second function or the shift. So x degree is equal to 49 degrees. If you punch cos, the inverse of cos 41,000 and 6,370, you are going to find 49 degrees. Let's try to look at another example here. Maybe this is our last example. Find the radius of the circle of latitude 60 degrees north, given that the radius of the Earth is 3,437 nautical miles. So we have been given the radius of the Earth in nautical miles as 3,439. So meaning that whatever we find should no longer be in kilometers but nautical miles. So radius is equal to radius of Earth cos x degrees. So radius is equal to the radius of the Earth is 3,437 times cos latitude is 60 degrees, so the degree is 60 degrees. Okay, so we're going to say radius is equal to, so the radius of the Earth has been given nautical miles as 3,437. So we are going to say 3,437 times cos 60 degrees is equivalent to half. So we are going to say radius is equal to, what is 3,437 times half? We're going to have 1,000. Okay, we're going to have 1,718.5. Now, in this case, it's a nautical miles because the radius of the Earth that was given in nautical miles. Okay, so we have an activity which is showing on the screen right now. Take note of the shaded statement on top. It's saying that the radius of the Earth to be 6,370 kilometers, or 3,437 nautical miles, meaning that whenever you are calculating for kilometers, that is the radius you use to calculate in kilometers. And when you are calculating in nautical miles, that means you use the radius in nautical miles. For example, the first question is saying, find the radius of the circle of latitude 45 degrees south. A, in kilometers. I expect you to use the radius of the Earth in as 6,370, okay, kilometers, because it's asking you to find in kilometers. All right, and if it is nautical miles, you use the one for nautical miles. I expect that all of you to submit this activity individually by inboxing me, and then you will receive your grades. Okay, thank you for watching and stay blessed.